start the chapter. Okay, this is chapter 12, Lean Supply Chain. Now, when we talk about lean, it means out of. So when you go buy meat, for example, you will find a lean meat means out of fat. And lean, anything that out of waste. So here we're going to talk about the lean supply chain. Now, in this chapter, we'll talk about explaining a lean production, illustrate how lean concept can be applied to supply chain process, analyze this supply chain process using the value stream mapping, and apply lean concept to service process. Now, what's a lean production? And we said in the it means without. So here is a lean production. It means integrated activity designed to achieve a high volume production using the minimum intervention and using a raw material, work in the process, and finished good. The customer value is something for which the customer is willing to pay. So for the customer has a customer has a value for it, willing to pay for it. When we speak about waste, we speak about anything that does not add value from the customer's perspectives. And timing, we need to look at the timing. So we need also to do a careful scheduling of activities. We need to set up some kind of a value chain, which is each step in supply chain should create a value. If an activity does not create a value, it should be removed. Lean production also involves the elimination of waste in a production effort, and lean production also involves the timing production resources, like the parts arrival, the next workstation at what time it's coming, the products, parts to the factory, and from each workstation to another workstation. Now, in the service operation waste, one of the causing is the uncertainties, which is uncertainty in the task time. You don't know when you're supposed to do that, when the customer shows up and requires some of your service, and uncertainty in demand. That's when the customer owns. But the task time, how long it takes, and customers' production rules. So you're not aware how long it takes to finish this because the customer will come and tell you what he is looking for, and you're not aware in the demand because you don't know when the demand is really at what level up and down. And the customers usually, customers' production rules. Anytime the customer shows up, there is a production. No customer shows up, there is no production. So when we talk about lean logic, a lean is based on the logic that nothing will be produced until it is needed. A sales plus a replacement, sales pulls a replacement from the last position in the system. So you don't move it until the sales remake requirement. You made the one sale, so they pull the different product accordingly from each stage. This trigger an order to the factory production time. Each upstream station then pulls from the next station further upstreams. We will see it in the next slide how it looks like. Here what's happened, let's say the customer comes in and want to buy something. So what we'll see a final assembly. When a customer buying something, then you start doing a final assembly for other things. And the final assembly will pull the sub products or sub assemblies, and the sub assemblies, is made of fabrication, different parts of it, and they will pull also. So this each level will pull the level before it until pulls from the suppliers or the vendor. So each stage of the system is tightly linked. Material is pulled through the system only when there is a demand for it. In the Toyota sample, which is they use they're a big fan and they're using a lean system, is first of all what they they do an elimination of waste. So there is a waste from overproduction, waste of waiting time, transportation waste, inventory waste, processing waste, waste of motion, waste of from product defect. I think if you go to any manufacturing, you might find some of these already they are doing it and wasting something and can be improved. There is a constant improvement in manufacturing or in the service also. Later on, we'll talk about services. So we can eliminate the waste. Waste is not the garbage that we throw outside. It is when I'm waiting for a unit to comes in order for me to work, that's a waste of time also. Now, on the other hand, Toyota, what they do, they have a respect for the people. They look at their employees as an asset. Lifetime employment for permanent positions, maintain level of payrolls, even when the business condition is deteriorates. There is a company unions, there is a bonuses they get, and they view the workers, as I said, as an assets. In a lean supply chain, there is what you call a value stream. The value adding and non-value adding activity required to design, order, and provide a product or a service. Very simple put is you look at each activity and you see if there is a adding a value or just not adding any values to the final product. And you have to put them in order. On the other hand, what you do a waste reduction is the optimization of the value added activities and eliminate non-value adding activities. So you look at each stage for a production, and if there is a value in them, you leave them. If there is no value in them, you just eliminate them, stop them. In general, I need you to take a look at this, but in general, is a lean focused supply chains component is from, they look at the lean suppliers, they look at the lean procurement, they look at the lean manufacturing, whether there is a lean warehousing, if there is a lean logistics and lean customers. And each one of them made of subcomponent that an employee and operation manager can take a look at it and improve it, take the waste out, make it more lean. Take a look at these elements under each one of them. In the value stream mapping is a special type of flow charting used to analyze where the value is not being added as a material flow through a process, useful for developing a lean process. We used a flow chart in this subject in the earlier chapters a lot. So we do a flow chart for a production. and find each stage and see where is the waste, where we eliminated, where is the values. It's a creating of a lean process requires a full understanding of the business, including a production process, material flows, and information flows. And each one of them, we can go on a detail, like a production process, how it's happening, the material, the move of the material, how it's happening, and the information, how it gets communicated. Now, the principle of lean supply chain design, you do a lean out or lean layout, which is a group technology. You put the group who specialize in technology in one field, quality at the source, we'll explain what is that, and GIT production, just-in-time production. The lean production schedule, excuse me, uniform plant loading. Then you use Kanban production control system, a Japanese control system, using the cards, you know, for memorizing or for processing, and provide a lean supply chain, which is specialized planet, work with suppliers, and build a lean supply chain. So in the lean concept, the plant layout designed to ensure the work balance workflow with a minimum of work in a process inventories. In other words, when something is moving from one position to another position, from one sector to another sector, the flow should be very smooth. There should not be a bottleneck. Preventive maintenance is emphasized to avoid the downtime. Currently, there is application who can help you to tell you these machines need, when it needs to be, to do a maintenance for them. So it's a product that I know is done by IBM, one of the product, who looks at these sound of the machine or the shaking of the machine to let you know when it's supposed to be done maintenance. Operate, which is operate to perform as much of the maintenance to keep the equipment reliable. Don't wait until the equipment breaks to change things, because that will slow down and make a bottleneck. The group technology, a philosophy in which a similar parts are grouped into families. And you will see in the next slide how it looks like, or this slide actually. The process required to make a part are arranged in a manufacturing cells, eliminate the movement of queue time between operation, reduce the inventories, and reduce employees. And this is what the work center looks like. If you notice, each group is doing one thing separately. That's the work center. Instead of this, you need to do a group technology. And instead of specialized work centers, you need to do a group technology cells, which is it operates smoothly to produce. And instead of having two grinders in one center, you put one grinder here, and maybe you need a second grinder there. If you saw a saw here, you have one saw here, one saw there, who is really, they are moving smoothly between them. Now we put a whole unit to produce a complete unit. Now the quality at the source, it means do it right the first time, and if something goes wrong, stop the process immediately. So you want to make sure, like what you do in the Six Sigma in a way. So you need to do it right. And if something goes wrong, don't just ignore it and pass it to the error, pass it to someone else. Because if you something wrong with, you built on it, everything goes wrong. And on the other hand, workers are personally responsible for the quality of their output. Workers become their own inspectors, so they check on their quality of their output, and workers are empowered to do their own maintenance or request their own maintenance. What we have, and we spoke so many times about it, the just-in-time or GIT production. Just-in-time production, producing what is needed when needed and nothing more. So if you need 5 units, you produce only 5 units, and when it is needed, today, tomorrow, or whenever. So anything over the minimum is waste, typically applied to a repetitive manufacturing, especially the assembly lines. Ideal lot size is 1, and the vendors ship several times a day, or the supplier. Just in time, the good part of it is can expose the problem. Otherwise, if you don't do it just in time, you might have the problems is sitting in a warehouse and nobody is aware of it. Now, in the lean supply chain, there's what you have this specialized plants, and then you have issues that you need to collaborate with the suppliers. In the specialized plant, small specialized plant rather than a large vertical manufacturing. So as we said, smaller, when you saw in the slide how they you do it as a small specialized plant. And can be constructed and operated, first of all, cheaper, and streamline management and bureaucratic align with lean philosophies. Collaboration with the supplier, that's a very important issue, important part of the process. Share the projection with the supplier so he's aware of your warehousing and when you're supposed to need to replenish your warehousing, and also your sales projection, your production, also aware about it. Link with the suppliers online as they do Johnson and Johnson. They link with a few suppliers online to make them aware when they need. Improve the communication, allows level of production scheduling. Issues that you need to look at it when you do a lean service, like organize a problem solving group, how you sit there as a group and solve the issues. Upgrade your housekeeping, things that have, causing you, slowing you down. Upgrade the quality of your service. You need to clarify the process flow, just like what you do in the production. Revise the equipment and process technology. See if they are helping you to improve your service or maintain a good service. Level the facility loads. Don't, you want to make sure we spoke about the lineup in the cashiers and supermarket, how you can level it up, the queue process. Eliminate unnecessary activities. So have things around the employee. You don't need to do things that extra that not necessary. Recognize the physical configuration. Introduce the demand pull instead of push scheduling, and develop a supplier network. You can, one of the good samples that demand pull scheduling, you see it in, you know, scheduling system that you see for coming when you go and book a haircut or something like that. So this is in the chapter.